All right, I've got another log example here from the SL analysis test. This one's pretty tricky. So it gives us two functions that are both log functions. And it asks us to do a couple things about this with this. So it says, first off, let's just figure out what the vertical asymptote is for g of x. And I remember that like your basic your basic log function has a graph that looks kind of like this. And so your vertical asymptote is just at x is equal to 0. And this g of x hasn't been moved horizontally at all. The only input there is just x by itself. So I know that x equals 0 is the vertical asymptote. That's not too bad. Then it asks us to figure out where the two graphs intersect. And it tells us that these two graphs intersect at two different points. So there's one curve going like that, and then there's another curve that comes, oh, that's a terrible color. Another curve that comes up like that. So there's one point here called P where they intersect, and another point here called Q where they intersect. Okay, and the P and the Q are just like the x values. So x equals P is one of the intersections, and x equals Q is the other intersection. So let's set these two things equal to each other and try to see if we can figure out where they intersect. So natural log of 2x minus 7 equals 2 ln x minus ln of d. So now we got to use some of our log rules. I'm not going to do anything to the left side yet, but I'm going to rewrite the right side like this. Natural log of x squared minus natural log of d. Just like when you add a power to an outside power, you can multiply the two powers. Here we've got a log with an outside multiplier, so we can make it a power on the inside. Just switching the exponent rule of power to a power to now being our log rule of multiplying in front is a power on the inside. I'm going to do one more log property on the right side. Subtraction between two logs with the same base becomes division inside of one log. It's just like if I did x to the 3 divided by x to the 2, I can go 3 minus 2 for the power. Same idea. Subtracting two logs becomes division inside of one log. Now I'm thinking, what's the inverse of a natural log? Well, the inverse of a natural log, because it's a log with a base of e, is an exponent with a base of e. So I can cancel that, and now I just have a nice quadratic equation. 2x minus 7 is x squared over d. Multiply everything by d, so 2dx minus 7d is x squared, and get it all equal to 0. Oops, get my face out of the way. 0 is x squared minus 2dx plus 7d. Okay. So it says they intersect at P and Q, and you can't figure out what P and Q are here because everything is just in terms of this letter D. They haven't told us anything about D. So they ask us to do a couple things. They ask us to show if D equals 10, find what Q minus P is. So I'll write that down. So one thing they ask us to do is if D equals 10, find Q minus P. We'll do that. And they want us to show that, in general, show that D squared, so I'll just write and, show that D squared minus 7D has to be greater than 0, and find the range of D. Okay. So I'll just do the D equals 10 part first, okay? So what I'm going to do is I'm going to clear everything out, and I'm just going to return to this part right here. Okay, so here we go. So we have 0 equals x squared minus 2dx plus 7d. and we're saying D equals 10, and we want to find Q minus B, which are the two different points of intersection. So let's make D equal 10. X squared minus 20x plus 70. So let's try to factor this. Is there anything that multiplies to make 70? I don't think so. 7 and 10, 35 and 2. I guess it's not nice numbers. So then we just got to do quadratic formula. So opposite of b plus or minus square root b squared 400 minus 4ac, 4 times 70 is 280 over 2a over 2. So we get 20 plus or minus root 120 over 2. And what they want to figure out is q minus p. So we're going to do the bigger one minus the smaller one. So it's going to look really nasty. We're going to take the bigger answer. We're going to subtract the smaller answer. But they have a common denominator, and so I can just subtract the tops. 20 minus 20 is going to cancel out. And so I just have root 120 minus negative root 20. So root 120 minus negative means plus root 120. I have 2 copies of root 120. Common denominator was 2. Cancel that out. I've just got square root of 120. They want me to find the answer simplified. So I have to think what goes into root 120. I could make that 4 times 30, I guess. So that'd be 2 root 30. And I don't think there are any other perfect squares that fit into 30. So let's leave our answer like that. So that was with if d is equal to 10. Now let's go back and look at that equation again. But let's just look at it in general. What we know is that there are 2 intersection points. And I want you to think about what has to be true for a quadratic if there's 2 intersection points. When we did the quadratic formula a second ago, we found that the intersection points were the opposite of b plus or minus the square root of b squared, so negative 2 squared is 4, d squared, minus 4ac, so 4 times 7 is 28, over 2a. And obviously we can't get an answer for this, without knowing what d is, but we do know that there's 2 intersection points, and the only way you can get 2 intersection points is if the stuff under the square root is positive. So we know that 4d squared minus 28d has to be positive. If it was negative, we wouldn't get any answers. And if it was 0, we would only get a single answer. Because 0 squared because adding 0 squared and subtracting 0 squared just gives you the same answer. But if the stuff under the square root's positive, if the discriminant's positive, you get 2 different roots. That's the same if I divide by 4 as getting d squared minus 7d is greater than 0. Okay? So how is it possible for d squared minus 7d to be greater than 0? I can factor out a d, and I have d times d minus 7 is greater than 0. Now ask yourself, how is it possible for 2 things to multiply to be greater than 0? In other words, what do you know about your 2 numbers if I tell you that their product, their multiplication, is positive? Now you know that there are only 2 possibilities. The only 2 possibilities are both positive numbers or both negative numbers. So how could we have both positive? The only way we could have both positive is if d is positive and d minus 7 is positive. And that would mean d is bigger than 7. And if d is bigger than 7, then d is also bigger than 0. So this is one of our conditions. Anytime d is bigger than 7, then d squared minus 7d is greater than 0. That means our square root's a positive number. That means our graphs intersect twice. If they're both negative, then we have d is less than 0, d minus 7 is less than 0. That would mean d is less than 7. But just because d is less than 7 is not enough for d to also be negative, okay? So we need to have that. So there are two different possibilities. Either D is less than 0 or D is greater than 7. Basically, there's this range of D values between 0 and 7, like D equals 1 or D equals 0.2. Those values would make it a negative under the square root. That'd be bad. If I made D exactly 0 or exactly 7, it'd be 0 under the square root. That would be bad because that would only give me one solution. So the only way that I have two solutions on the graph is if D is a negative number itself or if D is a positive number bigger than 7. All right, thanks for watching. Let me know if you got any other questions.